Scene script. Have you ever wondered how the universe began? What was there before the first stars and galaxies formed? Well, the best answer we have to this cosmic mystery is the Big Bang Theory. Delving into the realms of cosmology and astrophysics, the Big Bang Theory is our best scientific explanation for how the universe came to be. Imagine, if you will, all matter, energy, space, and time compressed into an infinitesimal, unimaginably small and hot point. This is what we refer to as a singularity. Around 13.8 billion years ago, this singularity underwent an incredible expansion. It was not an explosion but an expansion of space itself, giving birth to the universe as we know it. And even now, this expansion continues, with the universe constantly growing and evolving. The Big Bang Theory, while complex in its details, is fundamentally a simple concept. It's the story of how the universe began from a single point and has been expanding ever since. And while the Big Bang Theory might sound like a complex concept, it's actually quite simple when broken down. Before the bang, there was the singularity. But what exactly is a singularity? Imagine everything we know. All matter, all energy, every star, every galaxy, even space and time itself, compressed into an infinitely small, infinitely dense, and infinitely hot point. That's a singularity. It's a concept so extreme it bends our understanding of reality to its breaking point. In the singularity, the laws of physics as we understand them cease to apply. The very fabric of existence gets crumpled up so tightly that it becomes impossible to make sense of. It's like trying to look north when you're already standing at the North Pole. Every direction you look is south because north no longer has any meaning. This singularity, this everything and nothing, is where everything we know comes from. It's the point from which the universe expanded around approximately 13.8 billion years ago. So the singularity is where our cosmic story begins. From this tiny, unimaginable point, the universe began to expand. But how did this happen? The singularity, that infinitely hot and dense point, didn't just sit idle. It started to grow, to swell, to stretch in every direction, all at an incredible speed. This was not a mere explosion, it was an expansion of space itself. And as it expanded, it cooled. The intense heat and pressure began to drop. It was during this period that the foundations of space and time as we know them today were laid. The universe was no longer a singularity, but a rapidly growing expanse of space and time. But here's the real kicker. This expansion never stopped. Today, some 13.8 billion years later, the universe is still stretching, still growing. Every moment, galaxies are moving further apart, driven by this unceasing expansion. So you see, this expansion is not just a historical event, it's an ongoing process. But how do we know all this? What evidence do we have for the Big Bang? The Big Bang Theory isn't just a hypothesis drawn from thin air. It's supported by solid scientific evidence, one of the most compelling being the cosmic microwave background radiation, or CMB. Discovered in the mid-20th century, the CMB is a faint glow that permeates the universe. It's the afterglow of the Big Bang, a vestige of the intense heat of the early universe. The detection of this radiation bolstered the Big Bang Theory, providing a snapshot of the universe when it was just a few 100,000 years old. Another key piece of evidence is the formation of atoms. As the universe expanded and cooled, it made possible the creation of atoms. These atoms later grouped together to form stars and galaxies. The fact that we can observe these celestial bodies today is a testament to the Big Bang and the subsequent expansion of the universe. And speaking of expansion, the universe isn't just sitting idle, it's still growing. Observations of distant galaxies show that they are moving away from us, indicating that the universe is still in the process of expansion. This ongoing expansion is another cornerstone of the Big Bang Theory. It's also worth mentioning the abundance of light elements in the universe. The Big Bang Theory predicts that the early universe was a hot, dense place where protons and neutrons could combine to form helium. The amount of helium we see in the universe today is consistent with this prediction. So, while there are still many unanswered questions about the universe and its origins, the Big Bang Theory gives us a framework to understand how we got here. It's not just a story, it's a scientific theory grounded in observational evidence. While the Big Bang Theory doesn't explain everything, it's backed by a wealth of observational evidence. The Big Bang Theory explains a lot, but it also leaves us with some unanswered questions. As comprehensive as the theory is, it stops short of explaining what caused the Big Bang or what existed before it. This is where the limitations of the Big Bang theory come into play. The Big Bang theory describes the universe's development from a tiny, dense and hot state to the vast and cooler cosmos we see today. However, it doesn't explain why or how the singularity came to be in the first place. What caused such an incredibly dense and hot point to exist? What triggered its explosive expansion? Moreover, the concept of before the Big Bang is a puzzling one. If time itself began with the Big Bang, as the theory suggests, then the concept of before might not even apply. It's like asking what lies north of the North Pole. The question itself might not make sense in the context of our current understanding of space and time. Then there's the question of what lies beyond our observable universe. If the universe is indeed infinite, as some theories suggest, then what does that space look like? Is it filled with more galaxies, just like our own universe, or does it contain entirely different physics and realities? And let's not forget about dark matter and dark energy. These mysterious entities make up about 95% of the universe according to current estimates, yet we know next to nothing about them. How do they fit into the Big Bang theory and the evolution of the universe? These are just a few of the unanswered questions that make the story of our universe so intriguing. Scientists are continually pushing the boundaries of our knowledge, seeking answers to these questions and more. Despite these unanswered questions, the Big Bang theory remains our best explanation for the origin of the universe.